Okay, so we are going to begin section 2.5, and this is going to be one of the longer sections in this course. Certainly, probably the most intense section in chapter 2, because it has to deal with transformations, where we get to see really see the relationship between graphs and algebraic manipulation. So, in particular, we're going to see how even a formula for a function, if we do an algebraic substitution, how that actually corresponds to a certain transformation of the graph. And the key here is to see which transformations correspond to which substitutions correspond to which transformations. I want to start with an example here. Here's the graph of the square function, and then we have some graphs of some other functions, and you can see that, like in this first case, y equals x minus 1 quantity squared. All we've done here is replace x with x minus 1. That's the substitution, and we can see what the effect it has is it takes taken this graph and shifts it to the right 1 unit. And we're going to the right. That seems a little counterintuitive because you think, okay, we replace x with x minus 1, you would think it would go to the left, but in fact it goes to the right. And you can see why, because the y-intercept here is 1, and in fact when we plug in x equals 1 here, we get 0. So that's going to be, that has to be the x-intercept is 1 and not minus 1. And then similarly, we can see if we replace this x with x plus 1, we shift the graph to the left 1 unit. Okay, because again, you'll see that minus 1 will be the x-intercept. On the other hand, if we add 1 to the entire expression, this has the effect of shifting the graph up 1 unit. And if we subtract 1 from the whole expression, we shift it down 1 unit. If we put a minus sign in front of the whole expression, we are changing the sign of all the y-coordinates, so we actually have a reflection. We're reflecting the graph through the x-axis. And if we just change the sign of x, please keep in mind that this expression is different than this. In this case, we're not squaring the minus sign. In this case, we are, because we're basically replacing x with minus x. And we can see we get exactly the same graph, don't we? Because we just get, when we square the minus sign goes away. And then finally, if we look at the graph y equals 2x squared, we have we've got a vertical stretch of this graph, because we've basically multiplied all the y-coordinates by 2. Okay. So we're going to see that. So we can get an idea of what these transformations, what effect the substitutions have on the graphs. Another example is if we have we start with a square root function, and if we replace the x with x plus 4, well, again, you can see that this has the effect of shifting it along to the left 4 units, because in fact, if you weren't sure, even if you didn't see the graph, you could check that the domain has going to be all numbers greater than or equal to negative 4. So this shifts the graph to the left 4 units, and then if we stick with this and then subtract 1 from this whole thing, we basically shift this graph down by 1 unit. And so the point that used to be negative 4, 0 is now negative 4, negative 1, and you can see that everything else follows. Okay, so we can certainly apply more than one transformation or more than one substitution along this process, and a lot of times we'll look at graphs where we require several substitutions or several transformations.